sitting next to a swimming pool, and somebody dives in, and she's not too pretty, so I can think of something else. I think of the waves and things that have formed in the water. And when there's lots of people have dived in the pool, there's a very great choppiness of all these waves all over the water. And to think that it's possible, maybe, that in those waves is a clue as to what's happening in the pool. That some sort of insect or something with sufficient cleverness could sit in the corner of the pool and just be disturbed by the waves, and by the nature of the irregularities and bumping of the waves, have figured out who jumped in, where and when, and what's happening all over the pool. And that's what we're doing when we're looking at something. The light that comes out is waves, just like in the swimming pool, except in 3 dimensions instead of the 2 dimensions of the pool, as they're going in all directions. And we have an 1/8 of an inch black hole into which these things go, which is particularly sensitive to the parts of the waves that are coming in a particular direction. It's not particularly sensitive when they're coming in at the wrong angle, which we say is from the corner of our eye. And if we want to get more information in the corner of our eye, we swivel this ball about so that the hole moves from place to place. Then it's quite wonderful that we can figure out so easy. That's really because the light waves are easier than the waves in the water are a little bit more complicated. It would have been harder for the bug than for us, but it's the same idea, to figure out what the thing is that we're looking at a distance. And this is kind of incredible, because when I'm looking at you, someone standing to my left can see somebody who's standing at my right. That is, the light could be going right across this way, the waves are going this way, the waves are going this way, the waves are going this way. It's just a complete network. Now, it's easy to think of them as arrows passing each other, but that's not the way it is, because all it is something shaking. It's called the electric field, but we don't have to bother with what it is. It's just like the water height is going up and down. So there's some quantities shaking about here, and in a combination of motions that's so elaborate and complicated that that result is to produce an influence which makes me see you, at the same time completely undisturbed by the fact that there are influences that represent the other guy seeing him on this side. So that there's this tremendous mess of waves all over in space, which is the light bouncing around the room and going from one thing to the other. Because, of course, most of the room doesn't have 1/8 inch black holes. It's not interested in that light, but the light's there anyway. I mean, it bounces off this and it bounces off that, and all this is going on, and yet we can sort it out with this instrument. But beside all that, you see, those waves that I was talking about in the water, maybe they're so big, some of them, and then you could have slower swashes, which are longer and shorter. And perhaps our animal who's making his study is only using waves between this length and that length. So it turns out that the eye is only using waves between this length and that length, except those 2 lengths are 100 thousandths of an inch. 100 thousandths of an inch, maybe. And what about the slower swashes, the waves that go more slowly, that have a longer distance from crest to trough? Those represent heat. We feel those, but our eye doesn't see them focused very well. We don't, in fact, at all. The shorter waves are blue, the lighter, and the longer waves are red. But when it gets longer than that, we call it infrared. All this is in there at the same time. That's the heat. Pit vipers they got down here in the desert, they have a little thing that they can see the longer waves and pick out mice which are radiating their heat, their longer waves, by their body heat, by looking at them with this eye, which is the pit of the pit viper. But we aren't able to do that. And then these waves get longer and longer, and all through the same space, all these things are going on at the same time, so that in this space there's not only my vision of you, but information from Moscow radio that's being broadcast at the present moment, and the seeing of somebody from Peru. All the radio waves are just the same kind of waves, only longer waves. And there's the radar from the airplane, which is looking at the ground to figure out where it is, which is coming through this room at the same time. Plus the X-rays, cosmic rays, and all these other things, which are the same kind of waves, exactly the same waves, but shorter, faster, or longer, slower. It's exactly the same thing. So this big field, this area of irregular motions of this electric field, this vibration, contains this tremendous information, and it's all really there. That's what gets you. If you don't believe it, then you pick a piece of wire and connect it to a box. And in the wire, the electrons will be pushed back and forth by this electric field, sloshing just at the right speed for a certain kind of long ways. And you turn some knobs on the box to get the sloshing just right, and you hear Radio Moscow. So you know that it was there. How else did it get there? It was there all the time. It's only when you turn on the radio that you notice it. But that all these things are going through the room at the same time, which everybody knows. But you got to stop and think about it to really get the pleasure about the complexity, the inconceivable nature of nature.